Good morning, good afternoon, good evening, whenever you may be. It's another exciting day of science from the Brenna Bunker, somewhere in the southeast U.S., quarantined as everybody else is. Hope you guys are having a safe time out there. I appreciate everybody stopping by and saying hi and having a look-see at some science today. But today we're talking about the water cycle. As we continue our work in 7.E.1, this pops over into the second piece of the unit, but we're going to continue on with our work. So, once again, if you're watching this video, make sure you comment down in the comment section. That's how we're taking attendance these days. So say, hey, I was here down in the comments, then like and also subscribe to the channel. So as you can see down here, our can-do statement. I can describe the water cycle. You guys have had water cycle before. You had it in 5th grade, and I'm sure somebody has wandered into it in the 6th grade as well. So the water cycle, what is the water cycle? Well, the water cycle is the continuous movement of water between the oceans and other large bodies of water, the atmosphere, and land. Water moves as a solid in the form of snow, ice, sleet, a liquid in the form of rain droplets, runoff, and collection, and a gas in the form of water vapor as it evaporates, condenses, and freezes its way around the planet. When the water vapor or gas cools down by traveling higher in the atmosphere, it condenses to form tiny water droplets or ice crystals. It cools because, remember, the higher we go in the troposphere, the lower the temperature is. Small droplets or ice crystals are visible to us as clouds. When enough droplets have formed that they cannot remain airborne due to the gravity, they fall to Earth as precipitation. Temperature of the air at the time determine what form this precipitation takes. Below freezing, you get ice, snow, or sleet. Below freezing, you get rain. Some or all of this precipitation is re-evaporated before it reaches the ground. So, you guys have had this before. This is going to be a real quick lesson today, but we're going to bang over here to this this large picture. This kind of explains it all. But again, remember, the water cycle is not as simple as just a circle. The occasional thing, but I mean, you got all these arrows pointing up, you got all these arrows pointing down, you got all these arrows pointing left and right. It is a very complicated process, because here we got, so we start, let's just start over here. We got evaporation. We got evaporation here, we got evaporation from this lake, we got evaporation from the rain before it ever hits the ground. Oh wow, I just said that. We got condensation, which is where this evaporated air, water vapor, which is a gas, goes back into a liquid state. The liquid state it's in is what we see as clouds. Clouds are not gases. Clouds are groups of droplets of water or ice crystals with the real high clouds that have, wandered together to the point where they're visible to us on the ground as a big white puffy thing, or a gray puffy thing, or black puffy thing, depending on the, the light situation. And that's what we see. But that is actually, a solid, liquid or solid water when you see a cloud. It is not water vapor anymore. And there's another evaporation right there out of the cloud. So because that's what tells you this is a liquid. You can't evaporate a gas. It's already evaporated. So right there out of the clouds, got the arrow of evaporation. So now, here's some of the interesting ones. So the water from the lake, which would normally flow into, the ocean, so also goes down and percolates. So here's what we're going to talk about that. Sometimes some or all the precipitation is re-evaporated before it reaches the ground. Sometimes I've actually looked at weather radar. When you look at weather radar, you see, the green stuff. That denotes, precipitation. So we'll go grab up Wonder radar here. And we'll look at this radar, and we'll find some place that's actually where the rain is hitting the ground. One of the things you gotta remember with radar is that just because it shows green doesn't actually mean water is physically reaching the ground, and that's one of the things that is part of the water cycle, where that rain can start falling out of the cloud and then actually be re-evaporated before it ever hits the ground. Come on, slow over here out to Arkansas, Little Rock. Hey, Bill Clinton was from Little Rock. So anyway, well, where you got this yellow stuff, yeah, and the red stuff, yeah, that water's in the ground. But out here where it's just green somewhere, you can have rain where radar says, hey, there's rain here. It can be falling out of the cloud, but the cloud's high enough up and the temperature's such on the ground that this water coming out of the cloud doesn't actually hit the ground. It re-evaporates back into a gas before it hits the ground. And so sometimes you can be sitting under, looking at radar going, where's the rain? Because it looks like this on the radar, but yet nothing is reaching the ground because it's all re-evaporating before it hits the ground. So that can actually happen. So once that rain actually hits the ground, it's either soaks in or becomes runoff. When I say soaks in, I mean it literally goes down into the ground, doesn't run off. I have a huge problem in my backyard right now is because the ground is so hard, it's just clay, it's not really soil. All the water that doesn't soak in when it rains, it just runs off and runs out the back and is now creating a trench in the back of my yard, because the runoff is carrying away the dirt, erosion. So I'm having to work real hard because I don't get none of the water soaks into my yard because it's just clay. They scraped off all the good soil. I get to fix that. So runoff can re-evaporate. Those rivulets of water as they're running into and looking and collecting, but as they haven't hit a water source yet, they haven't hit a river or a stream yet, they can actually still re-evaporate right there. Then it collects in the rivers, and those rivers flow into lakes. And of course, any open body of water can have evaporation off of it. But also, at the bottom of these rivers and lakes, you can have a soil or surface that becomes permeable. And this is right here. Some runoff finds permeable ground and makes its way underground. Permeability is the ability of rock or sediment to allow water to flow through it. Well, it's not just water. It's it's a multitude of things that you can do that that have there. But right here, it's called percolation. You see over here on this arrow, pointing down. Infiltration is where the water just goes into the soil. That's what I said. I said the water's not going into my soil; it's just running off the top of it. I would love to have some infiltration of water to get down through the soil, because that way it feeds the plants better. But all mine is running off because the soil is too hard to infiltrate. So infiltration is where it soaks into the soil, where typically that's where this plant uptake happens, is from the infiltrated water in the soil. Percolation usually happens in permeable rock layers, sandstone, things like that, and they get down into the groundwater, noted down here. And groundwater in the top layers of soil can be used by plants through uptake. Groundwater that continues down and collects and deposits, deeper down, become an aquifer. And so there's aquifers all over the place. It's just levels of because remember, sediment and everything else gets laid down in layers and forms layers of rock. Some layers are more permeable than others, so you'll end up having a layer of rock somewhere down underground that is very permeable, and the water will infiltrate it, and it becomes an aquifer because that water just hangs out there at that level, and flows along where that level that layer of rock goes. So those are called aquifers, and humans use aquifers all over the planet as water sources. So now the other big chunk of the water cycle is, got to remember, the entire process is driven by the sun. Energy from the sun arrives here in the form of solar radiation. Infrared, visible light energy are the primary drivers of the water cycle. Remember when we talk about infrared and the visible light, we're referring to parts of the electromagnetic spectrum. Should have brushed against this in the fifth grade as well. So, but here's the spectrum. So, see up here it says increasing energy. So over here is low energy. Over here is high energy. Low energy has longer wavelengths. Wavelength is determined between between say this mark right here, where it crosses the zero boundary. It goes up, it comes down, and then when it goes up, so from here. Hello, annotate. What color are we today? We're blue. All right, that's fine. So if we right here to right here, so that is one wavelength. A cycle all the way up, a cycle all the way down, and back to the starting point. That's one wavelength. Then you get over here, and one wavelength is right there to right there. So it is much shorter. Distance between here and here, distance between here and here. Now, so wavelengths right here, down here in the spectrum, in the low energy side of things, AM, yes, that's AM radio. I'm sure you guys are familiar with that. Not. Then you have FM, then you have TV, then you have radar, like to see the airplanes in the air kind of radar. But look at the wavelength down here at AM radio. Wavelength 100 meters. So literally the wave of an AM radio station transmission from here to here is 100 meters. The 100 meter dash, yeah, that's how long that wave is. By the time we get down here to FM, it's a meter. It's a tenth of this distance. By the time we get up here into the radar situation, it's a centimeter. Then we move into infrared right there. Now, infrared, if you ever watch Predator or any of those movies where they put on the goggles and you see everything in, let's do this. So when you see this type of stuff, this is infrared. This is taking the heat energy, and what infrared is heat energy. This is taking the heat energy that an object is giving off. So you can see what it is here. It's a hand. And so the blue is cooler, and the red and up here to the purple is hotter. So you see this picture here. So these cars, the white is the hottest. The darkest blue over here is the coolest. There's some people walking down there pretty far away. So infrared is looking at the heat emitted by an object, not the light emitted by an object. So in a case where this could literally be pitch black, but by the heat given off by these objects, and there's black right there, I mean the sky, which is the coolest, you would be able to navigate and see by this, and that's why the military uses it. That's why you can see almost through things. Oh, there's that predator from that old movie. You can see almost through things because you can see heat sources inside of things. So here's an infrared shot of a house. You can see the heat coming out of the house in the windows. And around the windows, you can see the heat loss. And there's a hot, looks like some sort of dump truck that must have just got there. And there's the guy that just got out of that truck, but to walk in. But you can sometimes even see, depending on the scale and depending on how sensitive the object is, you can see into some buildings. Now, if you look at this picture right here, this is interesting because this guy has obviously just touched the surface here. I imagine he's probably standing in front of a blackboard. This is a classroom situation. He just touched the blackboard and pulled his hand away, but yet his hand warmed the board enough that the camera could still pick up where he just touched it. I thought that's pretty cool. So this is what infrared is. And so then, so the goggles, infrared vision takes um, the heat energy of an object and then turns it into a picture that we can see. Now, there is one other way to look at stuff at night, and it's night vision, which is light application, but we're not going to go into that because we're talking about infrared. But infrared is heat energy. So when you see at a restaurant, especially a fast food restaurant, the burgers that are already made sitting under what looks like a lamp, that lamp is showing some visible light, but most of what it's emitting is infrared. Um, we'll be back in just a second.